Welcome. It's great to have you all here with us. You know, if you're a scientist or an inventor, you probably like a good mystery. I have a young daughter who really likes mysteries. She loves reading about Sherlock Holmes. And she recently asked me, if Sherlock Holmes had kids, how would they go to school? I told her, well, they would go to homeschool. That's what I thought. Okay, someone will figure that out. Well, to all you inventors out there, here's a question. If you were trying to develop a next generation sunscreen that was, friendly to the environment, how would you go about it? Well, scientists in Japan decided to study bacteria. That's right. They looked at some bacteria that was in the hot springs in Thailand. And they found that by studying this, they discovered a natural UV blocking compound with impressive antioxidant power. So kind of a combo. And they say it's, unlike conventional sunscreens, it's biocompatible and potentially safer for both people and the environment. So it's kind of a win-win. So who would have thought that by studying bacteria, we'd be advancing technology? But that's how it goes sometimes, which is pretty exciting. Well, it's time to get it over to Dr. Joshua for How to Study with Acellus Gold.
Acellus World is right around the corner, and one of the things that we are really looking forward to are the commencement ceremonies where we get an opportunity to meet our Acellus Academy graduates. And we have students that are all over the country, in fact, even all around the world. And one of the really exciting things is to get a chance to meet so many different students from so many different backgrounds. And today I want you to meet two remarkable Acellus Academy graduates who traveled to commencement all the way from Guam. Let's meet the Lujan family.
Hi, I'm Nisi Abishai Lujan. I'm an Acellus Academy graduate and came straight from Guam.
Hi, I'm Malachi Johnson from Lujan, and I'm a graduate here at Acellus Academy.
I also do Olympic weightlifting with my brother Malachi. And I really love Acellus for that. I'm really grateful because of the flexibility and the fact that I can travel to do my competitions on other islands, different states, without the worry of missing classes and how that will affect my grade. My favorite teacher in Acellus Academy would be Dr. Pajay Manet because I'm a very emotional person, and she really helped me show me how to express them and how to handle them in different situations.
A word of advice for any new Acellus graduates is don't stop, keep going even when it's hard. And I want to thank my mom, my dad, and everyone who got me to where I am today.
Let's hear it for the Lujan family.
Well, it's time to get it over to Dr. John for the Technology Spotlight.
I want to tell you about a superhero material. I'm talking about carbon nanotubes. They are 100 times stronger than steel and 1,000 times longer than their diameter. And they are super conductive of electricity and heat. And there are a lot of really amazing things that you can do with them. I want to show you one that I brought. It's not actually actual size, but you get the idea. And it's made out of carbon atoms. And it's a single layer wall shaped into a circle. And then, if you can imagine, this keeps going. And this one isn't to scale, because its actual size would be about a millionth of a millimeter. If you can imagine that, I can't. Really small diameter. But if you were to magically make one of those this size, then it would go on for a mile or more. So if you can imagine that, this long hose going on for a mile, very dramatic size, and it has some amazing properties. Because of this special bond between the carbon atoms, we get a very strong structure. And you can kind of see the special shape, how each one of the atoms is connected to 3 other atoms with a really strong carbon bond. And if you were to cut this and roll it out, then you would have graphene. So it's really made out of graphene, which is another really amazing carbon material. And of course, diamonds are made out of carbon as well. So I guess it's a superhero family, not just one hero. Here's a depiction of a longer carbon nanotube. And there are a lot of really neat applications. And they were first discovered back in the 90s, around 1991. And it was really, really exciting. And we realized all these amazing applications. But then what happened? Turns out that they were pretty hard to make. If you're going to make carbon nanotubes, you need just the right environment. And the way that they usually do it is have an oven that gets really hot, like 800 degrees Celsius, really hot. And then they put in a carbon-containing gas, and the carbon atoms will deposit on their surface. They use something like silicon or nickel, or they have a lot of different materials that they start with, and the carbon atoms will grow into these carbon nanotubes. And here's a picture of one of those setups. You can see the oven there at the top, and then they put in the gas, the carbon-rich gas, and then if you see on the bottom, they grow those carbon nanotubes. And even though they're only a nanometer thick, they can grow them long enough that you can see them. And it looks like really, really soft felt or something. And here's a picture of some carbon nanotubes in a microscope. And you can see it looks like little teeny hairs. And again, they're really, really long. So let's think about some of the applications that we could do with this. Something that is really exciting that they've already started to do is to make stronger materials. They'll put the carbon nanotubes in a composite or something. For example, a lighter tennis racket. You can actually buy those today. But they're also looking at making armor, body armor, that's lighter and smaller. You know how they'll use something like Kevlar in the bulletproof vests? Well, this would allow the same type of protection with a lighter and smaller setup. And so a lot of applications like that, in aerospace and things like airplanes and spaceships, where lighter and stronger is a really big feature. But also, carbon nanotubes are really interesting for computing, because instead of using silicon as the semiconductor, like most of our computers today, you can use carbon nanotubes. And if they can figure out how to make them well enough, then this will allow for smaller transistors and faster and higher performance computers. So they're working on applications like that. And we've actually done some spotlights on that type of technology. But also, they're using them for quantum computers. This is like the next generation of computers where they use the carbon nanotubes to help hold the qubit state, which is, you know, in a normal computer, we have a 1 or a 0 for the bit. Well, in quantum computers, they have a 1 or a 0 or both. And it's a qubit. It's kind of confusing. But they're using carbon nanotubes there. And then another place that I wanted to talk about is in batteries. And this is kind of a neat, big thing that's going on right now, where our lithium-ion batteries are being enhanced with carbon nanotubes. Remember, lithium-ion batteries are the kind that they put in the phones to make it so they can last all day, or in the electric cars so you can drive as far as possible. And they found that they can use carbon nanotubes inside of the battery. Here's a diagram of one cell of a battery, and really the lithium-ion batteries will have lots of cells. But you can see how there's the anode and the cathode side, and they're actually putting carbon nanotubes in both of those sides. And remember how it helps distribute the heat, and also helps distribute the electricity and make the batteries work better. So by putting in carbon nanotubes, they're already getting higher performance, where the same size of battery can hold more energy, which means that if you put in an electric car, it could go further. Or if you put it in your phone will last longer, right? And then the other big feature is it makes the batteries last longer. You know how, I don't know if any of you have ever had this where your phone has this message that says, your battery life is poor or something like that, you know? And that's because every time you charge the phone up and then let it discharge, or any of these batteries, every time you do that, the battery gets weaker and weaker and weaker and holds less and less power. And so this technology could really improve the batteries, and they're already using them in actual electric vehicles because it increases the range so much. And so you might actually be interacting with carbon nanotubes already and not even realize it. There's a lot of really exciting applications. Like I say, of course, it's superconductive, so you could use it for power lines and be able to send electricity better. And one of the really outlandish ideas is that we could make a space elevator, because carbon nanotubes are theoretically strong enough that if you had a strand that, not just one carbon nanotube, but a collection of them, it could go all the way into space. And if you could have it go long enough that it goes all the way up to where the geosynchronous satellites are, and then go far enough to compensate for the weight pulling down towards Earth, then you could have a cable that just goes all the way up into space. And right now, if we want to get into space, we have to use a rocket and lots of energy and lots of fuel. But if we could just climb the cable, you know, not with our hands, maybe we'd have a motor do it, you know, then it could just lift lots and lots of weight into space really efficiently. And carbon nanotubes are theoretically strong enough and light enough to do that. Now, we're not even close to that because it's hard to make a carbon nanotube that's that strong and perfect. But it's theoretically possible. So with carbon nanotubes, the sky is literally not even the limit. Yeah, that's all the tech we have the time for. Thank you.
Now it's time for Breakthrough Moments in Science with Tobias.
So, you know, at Science Live, it's a time you want to pay attention. You know, when Dr. Billings teaches us something about technology or inventions, you want to take those things and put them in your brain. You know, kind of go like that. I mean, not visually, not actually, you know. That'd be a little weird. You imagine being in a business meeting and your boss tells you something important, you're like, got it, boss. And you better not forget, because the next week when you're there, your boss is probably going to go, told you on Tuesday. Okay, but no. You want to take these things you learn because you can build on existing technologies, on existing discoveries, and maybe do your own breakthrough. We're going to talk about a guy who did exactly that. And we're going to talk about Dov Moran, and he was pretty excited. He had gone to New York. He was from Israel, and he'd gone to New York to speak at an event where there were a couple hundred people in the audience, and this is in 1998. And he had a computer that had his presentation on it. So he's ready to give his presentation. He's up there, and his computer won't turn on. And he's trying to get it on. His whole presentation's there. It's a little bit tense, and everybody's seating, and finally he does end up getting it to work, thankfully, last second. And he gives his presentation. But he said this experience of being terrified that he might have no notes, no graphs or whatever he had in his presentation, made him think, I should have a backup. Like a backup computer? No, I should have a way to take this electronic presentation and put it on any computer. So he starts to look into how he could have a portable electronic backup of something like that, a file. How can you carry a file around, an electronic file? So what he ends up doing is he starts thinking through, okay, what are some of the ways that exist right now, back in the 90s, of being able to transport electronic files? So you might think of one of these things. He certainly did. Some of you guys are probably like, oh, look, someone made a statue of the save icon. Like, no, this is a floppy drive. This was a way of storing electronic files. And some of you might know that CDs were sometimes used to put files on. But we have to think about, what is computer data? And remember what that actually entails when we zoom all the way into what the computer sees. And remember, computers speak a language of just 2 words. Yep and nope. That's basically it. Can you imagine that? Hey, did you have a good day? Yep. How was Monday? Nope. It's like, that's all your vocabulary. That's what computers have. It's a yes or a no, or a 1 or a 0, right? So binary. So it's pretty simple because you just need each storage cell to have 2 states, an on or an off. So how you do that, though, can get pretty tedious. Now, one of the common ways at the time was disks, like magnetic disks, where each little cell where they would store a bit of the data could have a magnetic field that was pointing one way or flipped and pointing the other way for an on or an off, or a 1 or a 0. And that was one way that it was done at the time. So he was looking at all of this and trying to think, but I don't want something that has to spin. I don't need, I don't want to carry a big thing. I want a little thing I can put in my pocket and just somehow put it in this computer, and the computer has the files. Well, then he learns about an already existing invention and a discovery. And it was something that had been invented in Japan in the late 80s, so about 10 years previous, and it was a new way of being able to store electronic data. And basically, they used electronic charge, and they could charge these tiny cells, and they could put a charge in it or no charge. Now, when we're talking about this, we have to think about something they call volatile memory. And it's basically where they had an electronic storage where they had these little cells, and you could charge up each one or not have them charged, and that's your 1 or a 0. But then the moment you turn it off or unplug it, so it loses power, all of that data is gone because all the charge is gone, right? Well, they had found a way to make a non-volatile memory. So even you charge the different cells for loading all the 1s and the 0s, you unplug it, and it holds all of that data, even though it's unplugged. And so you're able to have that and carry it around. Even though it's not connected to power, you can reconnect it and have all that data still. And also, what about when you want to start fresh, erase all the data? In some of the systems, like with the magnetic thing and such, you had to go around and erase these cells. Well, with this new invention, they could erase sections really fast with 1 charge. And the story is that one of the assistants at the place that invented this described it as, it's so fast, it's like a flash. And they said, oh, we'll call it flash memory because it erases like a flash. And that was incredible. Well, when he starts learning about this, he gets really excited because that's perfect. So I can connect it to the computer, load the data and the 1s and 0s onto it, then disconnect it from power and the computer and put it in my pocket, and then later pull it out, and all the data's still there. And so he starts researching this and puts together a system. He has to learn all about it. Now, he needs a slick way to connect it to everybody's computer, though. You can't like pop open somebody's laptop at the conference and put it in there and solder it on somehow. You need a slick way to do it. So he starts researching different technologies that existed of how to connect something, and he learned about a fairly new standard called USB. And at the time, it had just started to be used in things like computer mice, some kinds of printers. And he looked at this and thought, oh, this is perfect. So we could have a little thing with this new connector on it, and all we need is the computer to have the USB on it. And they were starting to come out with more computers that had it. And so you would just plug this flash memory stick into the computer. And they worked on this, and in 1999, so not long later, they filed their first patent on it. And here is their first product of the USB flash drive. And this held 8 meg. And it was like, and he said that he gave the first one to his dad. And his dad had typed up a personal autobiography, and he said the whole book fit on the flash drive, which his dad thought was super awesome. He could carry his book in his pocket. But this would go on, of course, to become a way of storage for all kinds of I mean, we use it in SD cards and phones and all kinds of things. But he took different technologies that others had brought forth and figured out a way to bring them together in such a nice system that was so easy to use that it completely changed the industry. So when you're at things like Science Live, listen up, get ready to put it in your brain, because remember, your brain holds more than any flash drive. So fill it with the good stuff. Thank you.
All right. Well, it's time for me to introduce the father of hydrogen technology, Dr. Roger Billings. When early in his career, when he wasn't inventing hydrogen cars and hydrogen buses, hydrogen homes, and things like that, he developed the Billings microsystem, which was one of the very first all-in-one computers. Had a screen, had the keyboard, had the drives, not the little ones like Tobias was talking about, even bigger ones at the time. But he didn't just make the computer. There was no Windows to install at the time. So he and his team created an operating system, a spreadsheet program, and many other things to make it a complete product that really made an impact early on in computing. And it's changed a lot of things to this very day, which is pretty exciting. Please welcome Dr. Roger Billings.
Well, here we are.
Here we are.
And I'm like that young lady student that Joshua introduced, you know, the one that's emotional.
You're emotional?
And so I just wonder if you could settle me down a little bit.
With some intelligence? Emotional intelligence, are you saying?
Whatever it takes.
I think...
I'm still feeling emotional.
Are you? I'm a pretty emotional person, too.
Yes, she is. If you only knew.
How do you know how to teach that? You have to know that to teach a class.
Yeah, that's why we always film the lessons and edit them.
That's the truth right there.
Well, you know, it's fun hearing about flash drives and hearing about early computers, and boy, I have so many memories of getting into the computer field. And when I started out, I built the hydrogen car in high school for the science fair. And I want to talk about the science fair tonight because it has done so much to change my life. And I think it's done a lot to change the lives of a lot of other people because of the things I've been able to do that all started with and were inspired by the science fair. Did you know we have a science fair coming up this spring?
I heard it's coming right up, like in a couple months.
Well, it's actually a little more than a couple of months, a few months. But our science fair is a very, very big deal. And it's an international science fair. And when I was in high school, I'd been in love with science since the 3rd grade. So everything's science. And so now they were going to have a science fair. And I wanted so bad to be part of it and to excel in it. And so I built my project, which was a hydrogen-powered engine. And the inspiration behind it was when you burn hydrogen, you make this big fire, and all of the ash is water. Fire making water. And to me, that just was magical, and it still is. A lot of cars are making, a lot of companies are making hydrogen cars now that are pollution-free, and that's pretty exciting. But I just knew if I could get an engine to run on hydrogen, that it would change the world. And I worked very, very hard. It actually ended up taking me 3 years to finally get an engine to run. We've talked about that in other episodes. If you're interested, you can go back and check those out. But when the engine finally did run, I really believed that the whole world was just going to jump up and down and get excited and all want to use hydrogen. And I had a little tiny lawnmower engine running. And so then I upgraded it to my father's Model A Ford, which ran on hydrogen. And then to be a good scientist, I had to prove that in fact the exhaust was pollution-free. It was just water vapor. So I got a glass cylinder with 2 stopcocks, there's little valves, and I pulled a sample of the gas out of the exhaust, took it up to the laboratory of the nearby university where they ran it through an instrument called a gas chromatograph that would prove that there was no pollution in the exhaust. And horror of horrors,
Oh my.
there was pollution. There was a very toxic, evil, nasty, dirty, rotten gas
Oh my.
called nitric oxide.
Evil, dirty, rotten.
There couldn't be a pollution because when you burn hydrogen, you just get water. But when I burned the hydrogen, I got this icky stuff. And as I started looking at it, I learned that air, which is made up of 80% nitrogen and 20% oxygen, I rounded that off. When they get hot enough, these 2 gases react together and form nitric oxide. And inside my engine, it was getting hot enough to burn air, to cook air, to make it react and turn it into nitric oxide. I was devastated. My pollution-free car wasn't pollution-free. And I was just sure it was going to be. And it was right before the science fair. Right before.
So how old were you when you were doing this?
81. I was
That's
the
not
only
even
kid in high
possible
school with a
because-
beard. You know?
No, for reals.
I was 18 and 3 months years old.
Wow.
Yeah.
So you just graduated high school. You're-
So I was in high school, my senior year of high school. Now you're making me emotional. But at any rate, it really was there. And all gasoline or hydrocarbon engines create nitric oxide because they all cook air, they all heat it. But my engine generated a lot more nitric oxide pollution than gasoline engines did, because inside my engine it was hotter, and the hotter it is, the more nitric oxide reacts.
Wow.
And man, can you even imagine how emotional that made me? That's when I needed you, right then.
I was coming. I think it was.
I was coming.
I thought it was really hard, actually.
It was actually really
thought it was
disappointing,
really
and I had my charts all made for my display,
really?
you know, and cleans the air, pollution free, and everything. And I thought, what am I going to do?
Wow.
I thought, well, no one will know. I'll just no.
That's not what you
A
do.
scientist has to be searching for the real truth.
That's what a real scientist
And
is.
so I had to remake my charts, and I said, this is the world's first pollution-free car, but it isn't pollution-free. It was hard. And
Yeah.
I took it to our local regional science fair, and I won first place because, you know, it's almost a good project. And I also won a trip to the International Science Fair, which that year was held in the United States, in Dallas, Texas.
Okay.
So they even gave me the money to travel, and my chemistry teacher and I got on an airline. We flew to Dallas, Texas to go to this big science fair. And I'm there, I have my display, and these judges come around. They're all very grumpy.
They're grumpy.
Yeah.
Studious. Are they studious?
Why couldn't they get sweet
They're
judges?
grumpy.
Anyway, someone comes and says, oh, you have pollution. I'm sorry. But they didn't. And so the judges came around, and this one guy, he says, so you're saying your pollution-free car makes pollution? Yeah. And you're saying that the amount of pollution is more than a gasoline car? Yeah. And he says, well, what's the point? I'm still working on it.
Aww.
And he says, well, I'll tell you one thing. Congratulations to you for being honest.
That's a big thing.
And you know, in science, it's very, very, very important that we are honest about the research. When an unscrupulous individual does a research project and they publish it and they say they achieved a result which they didn't, it can throw a lot of people off and waste a lot of human capital trying to do things that don't work. So I said, no, it doesn't work, and but I think we can figure out a way to fix it. And that day I made a resolve. I'm going to find a way to get rid of that nitric oxide production. If we get rid of that, then we'd have just the greatest fuel system in the world. And I did spend the next years of my life working on it. The following year, I was at the university, and I wrote a big research paper of research I wanted to do to get rid of the nitric oxide coming from a hydrogen engine. And I sent it around, and Ford Motor Company got my proposal, and they said, we'll fund it. And so they gave me funding to study that problem, and by the end of my freshman year of college, we learned how to eliminate the nitric oxide. Whenever you heat air, some hydrogen and oxygen, some oxygen and some nitrogen join together and form nitric oxide. I found out that that's even a problem that Mother Nature has. Every time there's a bolt of lightning, it heats up air, and some of the air reacts together and forms nitric oxide. And thank goodness, because if it didn't, we would probably starve to death, because you need that nitrogen fixation to fertilize our plants. But lightning does just the right amount. My hydrogen car was enough to actually make people sick if everybody were driving hydrogen cars. But guess how I did it?
How'd you do it?
I realized, first of all, I studied the problem. I did a lot of reading, a lot of thinking, talking to a lot of very brilliant people, and I decided that the nitric oxide was coming because we cooked air. We heated up nitrogen and oxygen, so it turned into nitric oxide. So we either had to eliminate air or figure out how to make the temperature in the engine lower.
Okay.
If you make the engine temperature lower, you don't get as much power. Of course, we love power in our cars, don't we? But then I got a real clever idea one day, and the idea was, what about making a steam engine? And that's really how this idea came, a steam engine. When you take a drop of water and you heat it up and it flashes to steam, it expands 2,400 times, and that's how they power steam engines. Well, I thought, what if I could do that in my engine? So my idea was, I would spray in a mist of water into the chamber with the fuel and the air, and when I ignited it, the flame would be going through the chamber, and it hit these droplets of water. And the droplets of water would flash into steam, giving a lot of pressure to push the piston down, but lowering the temperature. And sure enough, it worked. We were able to clean the combustion so completely that at the clean air race a couple of years later, we had a car that the nitric oxide coming out and the pollution was less than the air going in.
Okay, it's time out. So are you saying...
I'm doing the timeout.
So are you saying because you were honest about your results that you were rewarded?
Did I say that?
Kind of did.
Well, I will say this. I don't know that because I was honest that I was later able to find the answer, but I will say this. Honesty is the best way to get to the end goal you want to achieve. Yeah. Now, just because I was honest doesn't mean I was going to find a solution, but it sure helped me get focused on the solution.
Yeah.
So I don't think you can say that honesty means you're going to always find the answer, but I will say this, it's my opinion that honesty is always the best policy. Mm-hmm. And I have learned in business that the people that really do things, that really make the big accomplishments, and especially in science, are the ones that are forthright and honest. And I recommend it to all sorts of people. But now that we got that all out of the way,
thank you.
Now I want to get into,
what?
The gritty part of this thing.
Okay.
You see, because I made it sound like, I did a car and we got a pollution, and we went to the science fair, but now here's the unofficial story.
That's the kind I like.
Mm-hmm. Yeah, it's our kind of story.
That's my kind of story.
Well, I had never been to Texas.
Okay.
And I'd never been in an airline. And I was pretty excited to go flying. And they even gave me money for a hotel room.
Wow.
I'd never stayed in a big hotel before. And they even gave me money to buy food. So I got down to Dallas, and here we are with all of these science fair winners from all over. And this isn't the science part of this, but anyway, there was one girl there. Yeah, there was one girl from a high school in Texarkana, Arkansas.
Okay.
So, that kind of straddles the line. She was from Arkansas, and she had won her local science fair, and she was just really a special young lady.
Yeah?
Yeah, and I immediately took a liking to her.
Because she was smart? Oh, no.
Yeah, she was smart. Of course, she won the science fair. But she was a very, very special lady. And when I met her, she had one of these things up over her hair, kind of a scarf thing, tied.
Yeah.
And I looked at that, and, I was developing my social skills.
Social skills.
So I went up to her and I said, "What is that thing?"
Oh, my goodness.
And you guys, that's not a good opening line. You can do better. What is that? And she said, "It's a babushka." And I remember that all these years. A babushka. I said, "A babushka." Oh, that's really interesting. Well, I absolutely became very, very fond of this young lady. And for a few years, we actually corresponded and got to be real good friends. And then one day, she disappeared.
Oh.
And so that's one of the challenges that I have in my scientific research, is to find that girl.
Really?
Yeah, I'd like to see how she's doing. It's been a long time. And so if you happen to know her, will you please let me know?
They might, actually.
Yeah. And what? Oh,
What's
yeah,
your
her
name?
name's Jane Braden. Jane Braden. I remember that name. And I remember she was from Texarkana, Arkansas. And I can remember she went to a Catholic school. And I remember a lot of things about her. But she disappeared. And I just wonder how she's doing. Now,
So
why
if you
am I
see her-
telling you this? How come this is on Science Live? We're going to get kicked off the air.
Zoom.
Like, well, I'll tell you why. Because science fairs are fun, and they develop your social skills, maybe not your emotional, but your social
Oh,
skills,
emotional, too.
and many, many, many other traits. And I want to put in a big, strong plug today for all of you students to do a science fair project this year. I really, really strongly want you to consider it. And it may be because you need to go meet someone named Jane Braden.
Or someone like that.
It was worth the whole science fair project to get to meet her. And you never know where these things are going to lead. And the hydrogen car got me my scholarship at the university, got me my first business, got me a lot of opportunities, and launched my career. The science fair to me was a game changer. A lot of people that do big things in the science fair don't even go on to be scientists, but it still was very helpful to them. Colleges really look at extracurricular activities like science fairs when they're awarding scholarships. If you're thinking about college, you really ought to do a science fair. That is why I'm announcing tonight the Roger Billings Medal of Science
Oh my.
award, which will be given out at this science fair this year
That's
by
so
me.
fun.
And I will be the judge.
Oh, really?
And the award will be for you to come and spend a visit at the International Academy of Science, and you'll attend the Science Live broadcast, and we will introduce you to everybody as the Medal of Science winner. And I hope that motivates one of you to work on a project.
Has your name on the
And we'll
award?
be talking about that a little bit later.
Love
But in the
that.
meantime, we need to get back down to our science quest, because we've been figuring out how radio came about, how it was discovered, how step by step by step. Remember, we talked about the coherer, and it could detect radio waves and so forth. Last time, the new proteges shared with us what they learned. This time, I asked them if they could look into and to teach us how a vacuum tube works. And I think we're ready to hear that. So let's roll the proteges.
Have you ever heard of an amplifier? An amplifier is used to boost the signal of something.
Like a guitar?
Like a guitar.
In the world of music, we use amplifiers to amplify the sound of our instruments. If I was playing to a crowd of 100,000 people and I sound like this, no one can hear me. But if I plug into an amplifier, but how do we do this? Our question today asks just that. How does a vacuum tube amplifier work? To understand that, let's go back to the 1800s. This is where we meet our inventor, Mr. Lee DeForest. Lee was born in 1873 in Iowa. Growing up, Lee was obsessed with radio. He even got a PhD writing a dissertation about the Hertzian radio wave, and even built his own version of the vacuum tube diode.
Now, at the time, radio was mainly used for transmitting Morse code signals. But there was a new type of radio that had just been invented. This is more along the lines of what we think of with radio today, where they would actually transmit voices over the radio waves. But this was still in the very early stages, and there were a lot of limitations. For example, they couldn't transmit very far yet, because the further they would transmit, the weaker the signal would become. Now, if you remember from last week, we talked about how they would pick up radio signals using a vacuum diode. Now remember, the vacuum tube diode works because of the Edison effect, where electrons are boiled off of the filament. But in the diode, there's also a plate. Anytime this plate is positive relative to the filament, then electrons jump across the vacuum to the plate, which completes the circuit. Now, Lee took this a step further, adding a third plate to his vacuum tube, taking it from a diode to a triode. Now, this third plate wasn't a solid metal plate, but it was made out of a wire mesh. So We could have a large potential difference between the plate and the filament, but all of that would be controlled by this third plate, by the mesh in the middle. How did he do that? If this third plate, or the grid as it would come to be known, has a negative charge, it repels electrons back to the filament. But if it has a positive charge, the electrons are attracted to it. Now, a lot of these electrons will miss the wire mesh and get accelerated onto the plate. This is how, with a small amount of energy, we can control a large amount of energy. I like to think of this like a stoplight. You can have a massive semi-truck zooming down the road, but when it approaches a stoplight, it comes to a stop. So with a tiny light, we are controlling massive vehicles. This is very similar to how a tiny amount of electricity can control a massive amount of electricity in an amplifier.
Now let's look at an experiment that shows this concept. So here we have a high voltage coming through our contraption here and running to a light, but the light is not on. However, when I push this button, the light comes on. Why is that? Well, we're using a very small current from this battery here running through a switch to control this magnet that will either pull the spoons together or release them. So this is a perfect example of a very small voltage controlling a big voltage. If we were to hook this light up to this battery, nothing would happen. It's not enough current, but we can control this massive amount of current that's coming from the wall to run our light.
Now this vacuum tube triode would go on to revolutionize the world of radio, allowing signals to travel farther and be picked up more clearly by receivers. Eventually, they would even be used in early computers, paving the way for transistors, microcontrollers, and computers as we know them today.
Using this simple concept of an amplifier, you can turn a concert for one into a concert for two. 2 million.
So there we have it.
Yep.
So you can take a wire and string it out to a tree, maybe back to your house, and the radio waves going through the air will create a microcurrent or electricity flow on that wire. That energy is too small to run your radio, but if you put it into the grid inside one of those tubes, it will amplify the signal and make it big enough to be able to even play your guitar for millions. Is that what that's what he's
That's
saying?
what he said.
Yeah, thank you guys. I thought that was very good.
They like the singing.
Oh yeah,
Yeah,
it's
Nathan
great.
loves to sing.
And they have got everybody so excited tonight about radio and vacuum tubes and how that works that even R51 has got
No.
excited. Yeah,
No,
he's into radio now too. Let's go down to
Radio.
Area 51
Okay.
and see what he's doing. These are no good. These are vacuum tubes. You use them for vacuum sweepers. If we don't use vacuum tubes, you don't need these. No. You don't need them because now we are a high-tech world and we have ways of doing things that is so much better. I have invented a way to communicate so you don't need radio waves. And here to help me is my lovely assistant, Dr. Paget Monet. How are you doing today? Okay. Will you help me? Okay. What we're going to do is demonstrate to the students how come you don't need radio waves anymore, because there's something better. I call it direct hardwire connection. Yeah, because Because you don't need radio waves. Let me show you. Look at these. I invented these. These are a couple of really neat things that you can do. And if you ever want to hear what's going on in this air, and you put up like, oh yeah. But you can use these to communicate. Let me show you how you work. You see, these have a direct string communication connection, and you can use that to send information back and forth, and it works like this. So I take this one like this, I put up like that, and I put over Lady Page. Hello, Lady Page, do you hear me? Can you hear her? She's saying she can. I really like you too. Oh, science is really, really fun. You don't need radio waves. OR51 this time, you're really missing everything. With a radio wave, you can transmit it out through the air and people can hear it all over the world. Everyone can hear it at once. You are off base. Okay. Oh, he just really poured a whole bunch of very cold hydrogen water on our idea, didn't he? And I just don't think that was very nice. I think this invention has a lot of potential, and kids could use these for the science fair. Did you know you can do an experiment where you put these two plastic cups work best? I tried them all. You connect them with a string, and you have to hold it real tight, and then you can talk to each other. And it's something you should do at home. You can do a science fair project, because guess what? This big string doesn't work as good as a fishing line. So you could try different kinds of strings, see which one works best. It could be your science fair project. But he kind of put cold water on our thing. Oh, wait a minute. He thinks that his is better because he can have his radio and he can just talk, and it goes all over the world. Everybody can hear it at once. But you can do that with my invention too. Shall we show him? Yeah, we will show him. Watch this. Let's show him what we really can do. So now I fix it. It's just like radio. When you talk into the cup, everybody can hear it at once. Look. OR51, you did it again. Can you guys all hear pretty good?
Well,
everybody can hear it at once.
All the different personalities right there.
And so we tuned into Science Live to learn that.
Goodness.
Okay.
Well, we
good.
have a question though.
Okay, question.
So you have ignited people's excitement on the science fair. However, we have some students who, as they put it, I'm really interested in the science fair, but I'm not the best in traditional science. But I'm really interested in architecture. Would that count as science too?
Yes.
That's Romina.
Yes, absolutely. Whatever your interest is.
Okay.
And you know, science is really the search for truth. It's the search for knowledge. And knowledge can be how to make a better football play, or how to make a better project of any type, how to even play a guitar, I suppose. Yeah. So you can have your science fair entry be anything that you want to research by using the scientific method. The scientific method applies to everything, and it's really a great thing to do. Now, I'm putting together a little paper on how to make a paper cup communicator. And I'm going to put it up tomorrow on the Science Live site, which is in the form of some ideas to help some of our younger students be able to make a science fair project where they can study these communicators, these R51 radios, and to find out what works best, and it'll be real interesting to see if some of you do that. If you do make those, be sure to upload photographs or video clips showing them so we can feature some of them on Science Live. Really okay, won't that be fun?
Yeah.
Now, I really feel that we're having a tremendous new year in Acellus, we're seeing the best student achievement we've ever seen, and that makes me really happy. In fact, we've had to really expand our manufacturing facility to try to keep up with the gold store. We didn't know the gold store could get so big, but it is, and it's fun, and it's exciting because you are understanding that when you put forth that effort to learn, that it empowers you, and you earn a little bit of gold now, but what's more important is that knowledge is going to stay with you, and you're going to earn gold year after year after year in your different careers. So please continue to study hard, and we'll look forward to seeing you next time. Thank you.